Hi, I'm Prof L and welcome to Chemistry Matters. And today, in the lab, we're going to learn how to do a titration. Now, titrations are a very, very important part of chemistry. They're very, very useful in determining the concentrations of unknown solutions by using known solutions to react with them. And that's the fundamental basis of a titration. A little bit of stoichiometry in there as well, obviously, doing the calculations in order to figure out your unknown concentration. So today we're going to do a classic acid-base titration. We are going to titrate hydrochloric acid against sodium hydroxide solution. And so in order to do a titration, the gear that you need, this guy here, a burette, a very accurate and precise way of delivering particular volumes, and that's pretty much about it, really. You need your solutions that you're going to titrate, obviously. So we have those here today. In our little Erlenmeyer flask here, we've got 20 mils of our hydrochloric acid solution. This is the solution whose concentration we don't know. And we are going to titrate in sodium hydroxide from our burette here. So, first thing that we need to do is to fill our burette. Here is our sodium hydroxide solution. We know the concentration of this. And the first thing that we need to do is to fill up our burette with this. Now, again, you might be tempted maybe, if you've got a particularly steady hand, to just fill it like that. Please don't be tempted to do that. No matter how steady your hand, it will run down the outside. So please get a little funnel and fill this up like so. Again, trying not to tip everything everywhere. And if you do it nice and steadily, you should be able to fill it up to the zero line up the top there. Okay? So, now it's always a good idea to overfill it just a little bit. There's not that much room to overfill here, but you'll see the reason why. Always, when you have filled up your burette, please take out the funnel. Don't leave it in there. That's a common mistake in doing titrations. Sometimes you see students with funnels in there. Obviously, you've got drops of your titrant in your funnel. They can come down and affect your reading. So don't do that. Right, so we've overfilled it a little bit. So the next thing we're going to do is to just run it down to the zero line, and realizing that we've got some volume in here that is just full of air at the moment. So let's just run that down a bit, and lo and behold, when we do that, you can see here now we've got a little air bubble like that. Okay, and again, that's another common mistake in titrations, is you'll see students with air bubbles in their burette tip like this. So how do we get rid of air bubbles? Obviously, just doing that is not enough. This one is particularly sticky, and so therefore the best way to get rid of air bubbles is the following. So take your burette out of its clamp, put it pretty much flat, or at least as flat as you can, and then just open the tap slowly, and that air bubble will disappear, just like that. Okay, and no air bubble now. So stick it back into your clamp, and now you'll find that you have to refill it, obviously, because you have taken out that air bubble. So fill it up now to just above the zero level, like so. And there we go, like that. Take out, again, your funnel, and now you're just going to very, very carefully just run down and take your meniscus so that it just hits that zero level, bang, like that. Okay, so now we're pretty much all set to go. We have our burette filled with sodium hydroxide solution. We've got our 20 mils of HCl that we've pipetted into our Erlenmeyer flask previously. So we're pretty much all set to go. Just remember, once you have done all this, you've got rid of your air bubbles and stuff like that, then make sure that you haven't got any sodium hydroxide on the tip of your burette. Just give that a little wipe like that to make sure that that isn't going to affect your titration results. Okay, so now we're all set. Here's our Erlenmeyer. We're going to put that under there like so. And another little tip, you're going to be shaking the Erlenmeyer. You're going to be swirling this as you're adding the sodium hydroxide. It's a really good idea to put the level of the tip of the burette below the level of the top of the Erlenmeyer, because that means that as you're swirling around, you're never going to miss the target, as it were. Okay, if you have this too high, you're shaking it around, you could very easily put some drops from the burette outside the Erlenmeyer. You don't want to do that. So we're pretty much good to go now. The one thing that we need to remember is to add our indicator. And in this case, our indicator is phenolphthalein, which is this stuff here. All you need is a couple of drops of indicator. That's it. Don't be tempted to put a huge, great squirt of indicator. More is definitely not necessarily better in this case. 2 drops will do you. You'll certainly see the color change with that. Okay, so technique. Now, I guess people have got different techniques for how they do a titration. I find the way that works for me, I'm right-handed, so I swirl the Erlenmeyer with my right hand and I operate the burette with my left hand, sort of wrapping it around the tap like so, okay? I find that you get a lot of control doing it like so. So we're all set to go. We're on the 0 line. We're swirling, 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 and away we go. So you can start off relatively quickly because it may well be that you have a fair idea of what your final titration volume is going to be. So you can fairly whiz through the first half or the first part of the titration anyway quite quickly. So being sure to swirl, swirl, swirl as you're adding your titrant, as you're adding your sodium hydroxide. And as we go on and on and on, what we should see is some pink drops as we get closer and closer and closer to the end point of the titration. So we're starting to get a bit close now, so I'm going to slow down and let's start adding our sodium hydroxide dropwise. And you'll find if you're doing this correctly, you do have really good control over the rate at which you add your titrant like this. And we should be getting near what we're going to call the end point now, and the end point of the titration is where your solution changes color. Okay, so now we're adding the sodium hydroxide dropwise, 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 and if you look very, very closely, you will see that as you add each drop, there's a tiny little bit of pink there that just persists until you swirl it away. Okay, and just a little bit of pink. So we are getting close. When the pink color starts persisting like that, you know that you're getting very, very close to your endpoint. Now you'll notice that I've put a piece of filter paper on the retort stand there, and that simply helps you visualize the very pale pink color. And gosh, there we go right there. You can see if you look very, very, very closely that you have got a very, very pale pink color persisting there. Extremely pale, quite hard to see. You've got to really, really look out for this, and that would then be the end point of your titration. Okay, a very, very pale pink color, and that has occurred at exactly, I would say, 19.95 milliliters there. Okay, so that would be what you would call, excuse me, the end point of your titration. Now, how do we know it's the end point? Well, if you're not absolutely certain that that's the end point, then one thing you can do is take your reading at that particular stage there and then add one more drop, okay? Or even part of one drop. And you might think, well, how can you add part of one drop? Well, again, if you are very, very careful here, you can get a drop sort of on the way, just doing it very, very carefully, and then you touch it on the side of the Erlenmeyer so that it'll run down into the solution. If it doesn't run down into the solution, then wash it down with some water, like so, okay? That's not going to affect the reading. And then if your solution goes pinker, is that a word? More pink, then you'll know that you were at the end point at that particular stage. Let's just add another drop or two and just ensure that we are there, because this is very, very pale indeed. Very, very pale indeed. And as you go past the end point, you can see that it is now getting darker. So we're pretty confident that that first very, very pale colour that we saw was in fact the end point. And so we've gone pretty much, I don't know, probably 5 or 6 drops now past the end point. So that very, very pale pink that you saw originally was in fact the end point. And all that you're doing now is adding extra sodium hydroxide, and you'll just be making the solution more and more pink. Okay, so that's pretty much the way that you do a titration. Now, your burette is normally graduated in divisions of 0.1 of a milliliter, which means that you can read it. You can read the volume to significantly better than 0.1 of a milliliter. Normally, the going rate at the moment now is 0.05 of a milliliter. Back in the day, you could really do it to plus or minus 0.02 of a milliliter if you were very, very careful. But certainly, when it comes to giving the results of your titration, don't, for goodness sake, say it's, for example, 19.9 milliliters. It's either 19.90 milliliters or 19.92, 90.94, 90.96, etc. You can do much better. You can get an extra significant figure over and above that first decimal place when you are reading the burette. Okay, the thing about titrations, they need to be reproducible. We've done one. In a perfect world, we would then do another titration and make sure that we get exactly the same volume of sodium hydroxide added as we did in our first one, or exactly the same within experimental uncertainty. And let's say the uncertainty here is probably going to be half of the smallest division, which is plus or minus 0.05 of a milliliter. And once you have got 2 titrations that agree, in other words, what we call concordant titrations, then that's it. You're all finished. You can now then go ahead and do your stoichiometry, which I've looked at in a separate video, and you can then calculate the concentration of your unknown solution. So that's pretty much everything about titrations. So good luck with those. I know you'll certainly be doing them either at school or in your chemistry labs. Hopefully you've learnt a tip or two today. So that's it from me for today. We'll see you in the next video when we learn how to use another piece of equipment. See you later.